everyone, and welcome to Lesson 7-2, Ratios in Similar Polygons. So today we're going to be looking at the basics of polygons that are similar, and then in our next few lessons we're going to be looking at other properties of them. So let's take a look. Okay, so the first question I have for you is, what does it mean for polygons to be similar? Now we've talked about similar polygons in the past, and you may remember it from pre-algebra. So what you're going to do is you're going to pause this, open up a Google Doc, write this question, and write down everything that you can remember. If you can't remember anything, that's okay. Just write, I can't remember. Okay, so go ahead and do that, and then come back here to see what we have to learn for today. So similar means having the same shape, but not necessarily the same size. And this little squiggly line, in Spanish you call it a tilde, is the symbol for similar. Okay, so if I wanted to note that two polygons are similar, I would use this symbol in between their two names. And similar polygons have two very specific properties. Their corresponding angles are congruent. So what that means in my two shapes over here is that if A corresponds to D, then those two angles have to have the exact same measurement. Same thing for B and E, and C and F. Okay, so notice I've written congruent statements for those angles. And that's something that you should practice, because that's one of the types of questions we'll have in this lesson, identifying congruent angles in similar polygons. Now, the other special fact is that their corresponding side lengths are proportional. And that's why we had that whole lesson on proportional. Okay, so what we do is we take the corresponding sides, and I like to look at the angles for help. This has one arc mark, and this has two. So AB is going to correspond to this one that connects the one arc mark to the two arc marks, DE. Okay, so I did AB over DE is 6/3, which reduces to 2. Okay, and then I did it for all three pairs of sides. So BC connects the two arc marks to the three arc marks. So BC is proportional to EF, because EF connects the two arc marks to the three arc marks. Okay, so I wrote a fraction and I reduced. And last, we have CA and FD. Notice CA connects 3 to 1, and FD connects 3 to 1. Okay, so again, I made a fraction and reduced. Okay, so all of these numbers that you get when you reduce those fractions should be the same. And that reduced form of the proportions is called a similarity ratio. And it describes by how much the shape has increased in size or decreased in size. I always look at the increase. So I always take the bigger shape divided by the smaller shape. So I know if I take this smaller shape number and multiply it by this ratio, I'm going to get the bigger shape number. Okay, and the last term I have for you is similarity statement. It's a statement that two shapes are similar, and it's very much like a congruent statement. You have to name the corresponding parts in the same order. So A and D corresponded because they were the angles that were congruent to each other. And then B and E correspond because they are also congruent to each other. And then C and F correspond. This is a similarity statement, just saying the shape name is similar to the other shape name. So let's take a look at an example. Okay, example 1 says to identify the pairs of congruent angles and corresponding sides. And I've given you the picture down here with our two triangles. So see if you can write down what those angle pairs would be, and see if you can make the fractions with those corresponding sides. And that's how we identify corresponding sides. We write those fractions, just like we had in our previous slide. So see if you can do it, and then come back here to check your answer. Okay, so what I realized is that angle R and angle Z both have one arc mark. So I knew that angle R is congruent to angle Z. Then I saw that angle Q has two arc marks, and angle Y also has two arc marks. So I said angle Q is congruent to angle Y. Now, angle S and angle X don't have any arc marks, but I know the third angle theorem. which says that if I have two pairs of congruent angles in two different triangles, then the third pair of angles is going to be congruent. So I know that angle S is congruent to angle X, even though they didn't put those congruent symbols in. Okay, so that's the first part, the pairs of congruent angles. Now for the corresponding sides, notice I made fractions. And I always like to do the bigger side over the smaller side, because when you reduce it, and if you use a calculator to do it, which is what I did, you can do the bigger one divided by the smaller one, and then it's pretty easy to get it into a fraction again, because we like these to be in fractions because they are similarity ratios, and ratios are fractions. Okay, so what I did is I said S doesn't have any arc marks and it's connected to R, which only has one, and X doesn't have any and it's connected to Z. So notice what they did is they flipped this triangle. So I have to be careful. 13.5 over 9 was my ratio, and then I divided it in a calculator. And then I did the same for RQ and ZY. R has 1, Q has 2. Okay, so I took the 18 and I went over the Z that has 1 and Y that has 2. So it's 18 over 12. Okay, and I reduced that. And then I did the same thing for QS. QS has 2 arc marks, S has no arc marks, Y has 2 arc marks, X has none, so I did 9 over 6, and I reduced that. So it's time for you to try it. Let's do a check it out question. So on that Google Doc you started earlier, you're going to add on this check it out question number 1. And you're going to be doing the same thing I just did in that example. So you need 3 pairs of congruent angles, and you need 3 fractions with those sides. Okay, so make sure you do that just like I did in the previous example. Okay, so pause this video, do that on your Google Doc, and then come back here. Okay, so in our last example, we were told that we had similar shapes. But in this one, we need to figure out if they're similar. But we're still going back to those same facts. So it says to determine if they're similar, and if they are, you have to write a similarity ratio and a similarity statement. So the first thing to check on these shapes is to determine if their angles are all, the corresponding ones are all congruent. So we check those first, and then we check to see if the corresponding sides are proportional. And to do that, we make fractions with the side lengths and then see if they come out to the same thing when we reduce them. And notice they've given you names to their shapes, and those names can be used to help you identify those corresponding parts. Okay, so pause this video, see if you can do it, and then come back here to see my answer. Okay, so these are rectangles, and I know that all of the angles of a rectangle are right, which means that they're all congruent. So all of these angles, it doesn't matter which one I pick, is going to be 90 degrees, which means that all of the angles in this red rectangle are going to be congruent to all of the angles in this blue triangle. So I don't have to worry about the angles. Now let's look at the sides. I see that TW is going to correspond to PS. So what I did is I wrote a fraction with TW, which is 6, over PS, which is 4. So I did 6 over 4, and that reduces to 3 over 2. Now, for the other side, I know that PQ, which is the first 2 letters, corresponds to TU, which is the first 2 letters. So I did 16 over 12. And I always do bigger over smaller. And it's good to have a rule about that in your brain so that you don't accidentally confuse yourself and do small over big and then big over small. You want to be careful. But 16 over 12 reduces to 4/3. Now, these are not equal ratios. So the sides are not proportional, and these rectangles are not similar. Let's look at another example. In this example, they told us that they have triangle ABC and triangle DEF. So pause this video and see if you can do the same thing we just did. Okay, so what I did is I used the arc marks to identify congruent angles. So A and D are congruent because they have 1 arc mark. B and E are congruent because they have 2. And then again, I'm going to use the third angle theorem for C and F. So I have all three pairs of angles that are congruent. So that worked. Now, again, I used the arc marks to help me identify sides that should be proportional. So A to B is one arc mark to 2. So that's D to E. So I did 20 over 15 right here, 20 over 15, and I reduced to 4/3. Okay, I did B to C is 2 to none, 24, and I did 2 to none is 18. So I did 24 over 18, and that reduces to 4/3. And finally, I did C to A, which is none to 1, and F to D, which is none to 1. So 16 over 12 is 4/3. So they reduced all to the same fraction, which means that those sides are proportional. So I wrote a similarity statement that says ABC is similar to DEF, and the similarity ratio is this reduced fraction right here, 4/3. So now it's your turn. Okay, so check it out. Question number 2 wants you to determine if triangle JLM is similar to triangle NPS, and if it is, write a similarity ratio and a similarity statement. So go ahead and do that on your Google Doc and then come back for our last example. Okay, so example 3 says a rail boxcar can be used to transport auto parts. If the length of the actual boxcar is 50 feet, find the height of the actual boxcar to the nearest tenth of a foot. A scale drawing is provided below. Okay, so what this is this is a model that shows the length and the height of the boxcar in inches. So you're going to be doing the same thing that we did in the last example of lesson 1. So see if you can do that and then come back here to check your answer. Okay, so what I remembered was that the dimensions are proportional. Okay, so I set up a proportion, and I like to do height over length equals the height over the length. So I set up this proportion, and I used a cross product to solve it, and I got 14.3. So this height is approximately 14.3 feet. So now you have one to try. Okay, so check it out. Number 3 is the last thing for your Google Doc. It says, a boxcar has the dimensions shown. A model of the boxcar is 1.25 inches wide. Find the length of the model to the nearest inch. So go ahead and do that on your Google Doc, and that's it for this lesson. So let me know if you have any questions, and I'll talk to you soon. Bye.